Welcome to HashiTalks 2025. I'm presenting a real-world industrial use case where we can build a secure, scalable data pipeline with Terraform and GCP. I'm Shruti Era Harera. I'm a data engineer at Telus International, and this talk is about a project where we had to design a pipeline that was secure from ground up, scaled to millions of daily events integrated with legacy systems, and still pass the compliance audits. What makes this different from my conference example is that it's not theoretical. This is from a real industrial environment. If a pipeline fails here, it's not just the dashboards that go blank, it can impact manufacturing timelines, shipment schedules, or even field operations. So over the next 15 minutes, I'll walk you through the architecture, the Terraform design, the security integrations, and the lessons we learned, including a code walkthrough so you can see exactly how we put the security into the practice. Let's start by understanding the context and why this pipeline was particularly challenging. So a quick intro about me, so you know where I'm coming from. I have over 6 years of experience in large-scale cloud data platforms like Google Cloud and Azure, and my work has been ranged from streaming data ingestion to machine learning pipelines, but my favorite projects are in industrial IoT because they combine like a huge data volumes, real-time processing, and strict compliance requirements. The project you're about to see reflects a lot of these principles like modular design, automation, and security as first-class citizen. So today this is how we are going to have our session. So that I'll be handling the challenges of the industrial telemetry at scale, and followed by the architecture and a Terraform module walkthrough, and then how we built in the security observability and optimization and the results and lessons we learned from that, and then we'll be taking questions. So let's begin with the problem we had to solve. We had to design a telemetry platform for an industrial client that met our four major challenges. So those were like the volume, security, reliability, and integration. So when it comes to volumes, we were receiving millions of daily events from sensors on equipments. Peaks about like 5,000 events per second, and these events weren't even uniform. We'd get like tiny status updates and huge diagnostic payloads, often like in different formats. So that was our volume issue. And with security, it was like a sensitive operational data, and if it leaked or tampered with, it could cause not only financial loss but also like operational disruptions. So we had regulations like SOX, GDPR, and enforce encryptions at the rest and in transit, and implement fine-grained access control. And we had to have the reliability, as this was like mission critical, and we had SLAs of up to 99.9% uptime with no data loss tolerated, and downtime could cost like hundreds of thousands of dollars per hour lost in production. And to do the integration, the data sources included like industrial protocols like Modbus and OPC cloud systems, and these had to be securely bridged with cloud systems while keeping IT and OT networks segregated. All of these requirements meant we couldn't just spin up a couple of managed services and call it a day. We needed a cloud native architecture defined entirely as cloud with built-in security and auditability. The entire system is provisioned and connected via Terraform. That means we can create any environment, dev, test, or prod from scratch within minutes with consistent security configuration. So here's a high-level architecture we implemented. We had edge collection, so the IoT devices with local buffering, so the data isn't lost if the network goes down. Data is encrypted before leaving the device and then passed on to the ingestion layer, where the cloud IoT core and PubSub for durable messages queuing. So this lets us absorb spikes without losing messages and decouple producers from consumers. And then we had the processing layer where we use the Dataflow with Apache Beam for real-time ETL. Dataflow scales automatically and can handle different payload sizes efficiently. And this was followed by the storage layer. The BigQuery for analytics was used and cloud storage for raw archives. The archives are essential for compliance and for reprocessing data if downstream model or query needs historical data. And this is an example of our Terraform implementation. So we had our repo organized like environments and modules and scripts. Environments had like dev, test, prod, each with its own state and variables. And modules had reusable building blocks for PubSub, Dataflow, BigQuery, IAM, and monitoring. And scripts are like helper automation for CI/CD integration. This structure allows isolated testing and promotes like reusability across the projects. So this is an example of a pub subcode. It provisions a topic for telemetry ingestion, a subscription for processing, IAM binding with least privileges, and 24-hour message retention. This parameterized so we can use the same module in multiple projects without rewriting. And the key here is that security is baked into the module. If you use this module, you cannot accidentally create a topic without the right IAM. It's like the part of the definition. And coming to its security implementation, we approached it in 3 layers. So the first layer is IAM management via Terraform, and then we had a secret management and then network security. And so the IAM management, we had custom roles per services, environment-based conditional bindings, and separate accounts for read and write operations. For secret, we had integration with Vault for dynamic secrets, no static keys in Terraform state, no secrets in Git. Keys are rotated automatically. For network, we had VPC service controls to prevent data exfiltration. All of these settings live in Terraform, so they are version controlled and peer reviewed like other changes. And coming to the observability and monitoring, one of the key principles we followed in this project was if you can define it in Terraform, you can also monitor it in Terraform. So observability isn't something we added at the end, it is built alongside the infrastructure. We use Terraform Datadog provider to create the entire monitoring stack programmatically. Let me break this down. So first we collect the custom metrics from the GCP servers through the API. Second, we build the detailed Dataflow job telemetry dashboards. And third, we create the automated alert thresholds by the environment. So here is an example of how we created the Datadog monitor. And the benefit of doing all this in Terraform is that it's repeatable. We can spin up a new region or environment, the same dashboard, monitors, and thresholds are created instantly. No manual clicking around like in Datadog. And finally, because of these monitors are in code, so they go through like the peer review. So the deployment delivered like up to 99.98% uptime and sustained like peaks of over 5,000 events per second, and it was like 40% faster processing times than the previous solutions, and 15-minute deployments from commit to production, and we had like 0 critical findings in an external security audit. So the key takeaways from this build is that we need to invest in modular Terraform from day one so that dev, test, and prod stay identical and repeatable, and implement IAM dynamic secrets, encryption, and VPC controls so the security is there by design. And when it comes to observability first, Datadog monitors and dashboards in Terraforms with SLOs and cost guardrails versioned alongside the infra. And team enablement, we have document modules and create usable patterns to scale the knowledge and enforce CI/CD, so new services inherit good patterns automatically. So if you copy one thing from this talk, start with a modular transform and add a vault early and ship monitors the same days you ship the infrastructure. And I have a small demo on the Terraform module structure here. And let's walk through the secure pub/sub pipeline with the Vault integration. And so we have like the source, the version, the topic, and we have the subscriptions that we are required. And this creates the topic subscription and applies least privilege IAM and sets a retention policy. So this is followed by the Vault integration. So in Terraform, we configure Vault GCP secrets in backend. So this tells the Vault it can issue short-lived keys for our pipelines SA with only publisher rights. So the Vault issues short-lived auto-rotated credentials for our pipelines, no static keys in Terraform state or repos. Every secret access is logged for compliance and permissions are restricted to exactly what is needed. For example, just the pub/sub.publisher and BigQuery.dataEditor. This greatly reduces the risks and simplifies the audits. And during the runtime, we have like the Terraform provisions infra and Vault config. We have pipeline job starts. We have Vault issues to key validate for an hour. And we have like job publishing messages and key expires automatically. So this way, no long-lived keys exist anymore, and we can pass audits without scrambling for key rotation logs. So the future directions and innovations lead us to AI/ML prediction scaling to anticipate load before it happens, and zero trust architecture for continuous verification of every request, multi-load Terraform modules for probability across providers, GitOps workflows to validate and deploy infra changes automatically. And then the performance optimization techniques, we tuned Dataflow autoscaling, used custom machine types, and enabled the streaming engine for throughput. In BigQuery, we applied partitioning, clustering, and materialized view to reduce costs and query times. And when it comes to network design, we use the VPC service controls and private Google access and regional deployment to improve security and lower costs. So the real world implementation challenges that we faced are like the state locking issues fixed with CI/CD management deployments, credential rotation gaps, like over permissive IAM roles, and uneven scaling too. So like this credential rotation gap was solved with overlapping validity. Over permissive IAM roles was replaced with custom least privilege roles, and uneven scaling resolved with backlog based auto scaling and dead letter queues. So if you have any questions, you can always contact me with this details. And thank you for your time, and I hope these patterns from modular Terraform to Vault-based secrets help you design pipelines that are secure, scalable, and cost efficient from day one. Thank you.